Hello everyone, let's start with the next part. So in this I would be covering types of reaction. So let's start with the first part. So it says combination reaction. Now combination reaction. Now from term itself we can make up a mind, like in this case we have a word combination. Combination means that there are two substances or there could be three substances. They will react together to form a new single substance. So on the left hand side you could have two or more substances and you will get a single substance only. So the definition says the reaction in which two or more substances combine to form a new single substance is known as combination reaction. Now, so you must remember the general equation to know about combination reaction. So it is very simple that A plus B forms C. A new compound is formed or a single substance is formed as a product. Now, very important equation is there, that is with calcium oxide and hydrogen. So what happens when calcium oxide reacts with H2O? Now you can see that this is again a combination reaction. Why it is a combination reaction? Because we have two reactants here, that is calcium oxide and water, and when calcium oxide reacts with water it forms calcium hydroxide. So this could behave as A, this could behave as B, and this would be C. So you can see that it is a type of combination reaction. Now we have burning of coal. Burning of coal is again a type of combination reaction. Why? Because we get carbon dioxide. We have carbon dioxide. When reacts with oxygen, it forms carbon dioxide, and heat and light energy is released. Now somebody could ask me like why there is heat and light when you said that we need only one compound as product. So we get only one substance here. Heat and light can't be considered under substance here. So heat and light couldn't be considered under substance. So we have carbon when reacts with oxygen forms carbon dioxide. Now in the third part we have formation of water. Formation of water is again a type of combination reaction. Why? Because we have hydrogen and we have oxygen, and when hydrogen and oxygen combines it forms H2O. So we have only one substance as their product. So we can consider it as a combination reaction. Now under combination reaction there are two types. Actually there is one type only given in book, and after some point we have endothermic. So here I have made a difference between exothermic and endothermic. So this is very simple. In exothermic, reaction in which heat is released alongside products. So in this case we get heat as a product. So as we have done this burning of coal could be considered as exothermic reaction as well. Why? Because we have heat as the product alongside other substances. So therefore we can consider burning of coal as exothermic reaction. Whenever we have heat as a product, we can say that it would be an exothermic. Now what endothermic is? In endothermic they need heat, light or electricity to initiate the reaction. That means they need heat, light and electricity as their product. So if they get heat, light and electricity as their product, they would be considered as endothermic reactions. So I hope it would be clear the difference between exothermic and endothermic. Then I will move on to decomposition reaction, that is the second type of reaction. So in this we have decomposition reaction. From the word itself again you can recognize the words and you can make up your mind what they are actually. Decomposition means like breaking down of a substance. So in this we have only one substance as a reactant. Only one reactant is there and we get many substances as their product. So the general equation could be like we have A as a substance and we might get B plus C and many other compounds here. So this type will be decomposition reaction. So now types of decomposition reaction are three. First is thermal, second is electrolyte, then we have third as photodecomposition. So the first one is very important, that is thermal decomposition. This example is very important. Thermal decomposition is a reaction when carried out under heat. So FeSO4 when burns in the presence of air, it gets converted or it gets reduced to Fe2O3, that is ferric oxide, and sulfur dioxide and sulfur trioxide. It could have two or more substances as their end products. So therefore we say it is a thermal decomposition. Thermal decomposition means that under heat. So you must remember that we have ferrous sulfate. Ferrous sulfate is in green color and green color gets converted into reddish brown color, that is ferric oxide. Now the next is electrolytic decomposition. Electrolytic decomposition is carried out under electric current. Remember this, electric current. Now we have H2O. Now we take electrolyte as H2O. I will show you the figure for same. So what we need to do is, what our aim is to do is, we have water. Now we need to get hydrogen and oxygen out of it. So what we will do is, we will electrolyte the solution. We will take electrolyte solution as H2O and break down into H2 plus O2, hydrogen and oxygen. Now here we have a setup. This is called electrolytic decomposition. Electrolytic decomposition, or we can say the activity to decompose water into hydrogen gas and oxygen gas. Now here we have anode that is positively charged and we have cathode that is negatively charged. Now I will tell you one term, that is panic. Panic is positive is anode, positive is anode, negative is cathode. This will make you easy to remember that positive is anode, positively charged carbon is anode and negatively charged carbon is cathode. Here we use graphite cells. These red and the purple one are the graphite cells to make this circuit electrically stable. So in this case, here in between the beaker we have water. Now why water? Because we want to reduce water into hydrogen and oxygen. So therefore this is my electrolyte. This is my electrolyte and I want water to break down into hydrogen and oxygen gas. So in this case we have electrolyte water. Now water, H2O. Now this can be, when we switch on the circuit, as soon as we switch on the circuit, it gets break down into H plus ion and O2 minus ions. So in this case we have positively charged ions and we have negatively charged ions. So in this case, whatever the positive charges, that is H plus, will go to cathode and they will get collected here. We will have all the H plus ions here. Why H plus ions would be at cathode? Because we know that negative and positive attracts each other. So in this case, H plus goes to cathode, all H plus ions will go to cathode and will form hydrogen gas here. Now you can see the empty space above small tubes. So you can see that we have more H2 gas as compared to oxygen gas. Now I will tell you about oxygen. So oxygen will get collected to anode. Why they are coming to anode is because they all are negatively charged, and negatively charged goes to anode because positive and negative gets attracted. So now you can make one more conclusion from here. One more conclusion from this activity is that H2 gas is more in number as compared to oxygen gas. So this is your experiment for electrolytic decomposition. Now the next is photodecomposition. So photodecomposition is a decomposition reaction carried out by sunlight. So whenever we do any experiment related to sunlight, then we consider to be as photodecomposition reaction. So again, one very important example here, that we have silver bromide. Now when you keep silver bromide in sunlight, it will get reduced to Ag and bromine. Now how would you say that it has been reduced? See, this is bromine gas, and on the other hand we have silver bromide. Now this is of red color, or I think brown color. So when you keep it in a sunlight, it will get converted into Ag, that is silver. So it will change its color. So therefore you can say that chemical reaction has been taken place. Now in the second one we get bromine gas, and this bromine gas will be went into environment. So here from the change in color state, we can say that it has been a decomposition reaction and we have received silver at the product end. Now the next is displacement reaction. In displacement reaction, this you have learned in class 8. This is very easy actually. So chemical reaction in which an element displaces another element from its solution. Now we have two things here. First one is element. Why element? Because it is a single atom, made up of single atom, that is Fe. And the another one is compound. So in compound we have copper as metal, and in element we have Fe. Now this element, that is Fe, will replace copper. Now why it will replace copper is because when they react together, Fe being more reactive than copper, it will displace this element and form ferrous sulfate and copper. The condition for displacement reaction is that the first element must be more reactive than the other element. If it is not more reactive, it won't displace the element here. So you must remember the condition. The condition is first element must be more reactive than second element. For that you need to learn reactivity series. Now the next is double displacement reaction. Now I will tell you the difference between displacement and double displacement. So in displacement reaction you can see the first one is element, the second one is compound. In the double displacement reaction, the first one is compound and the second one too is compound. So remember, in double displacement reaction you have two compounds, and in displacement reaction we need to take one element and we need to take other as compound. So in this case what happened is, here we have change is in ions. Now we know that Na will form ion, SO4 will form ion, barium will form ion, chloride will form ion. So therefore there will be a displacement of ions here. Na will come to Ba and Ba will come to Na. So you can see that we get product as barium sulfate and second product as sodium chloride. So that's how the double displacement reaction occurs. So here we have change in atoms or ions. Now in this case, one very important thing is that they give is that we have a barium sulfate, and barium sulfate is a precipitate. Now what precipitate is? Precipitate is a insoluble substance. That means it won't be soluble in water or any other liquid. So therefore we get BaSO4 and it floats on the surface of water, and it won't react with water or won't be mixed into water. So the white substance formed here is barium sulfate, and it is known as precipitate. Why precipitate? Because it is insoluble substance. Now I have given you some important information here, that is precipitation reaction. Now any reaction that produces a precipitate is called precipitation reaction. Now in this case you can see we have lead nitrate when reacts with potassium iodide will form potassium iodide. Sorry, there is a mistake. It will be lead iodide. And the second is potassium nitrate. Now what here, the downward facing arrow, you can see that PbI2 is with downward facing arrow. Now why it is with downward facing arrow is because it has formed the precipitate, and precipitate we know is white in color and it is an insoluble substance. So here we are with another example for precipitation reaction. The above one can be considered to be a precipitation reaction again, and the second one I have given you is again to be considered a precipitation reaction. Now in the next video I would be covering oxidation, reduction, redox, and we are left with oxidation and we are left with rancidity. So stay tuned with us. Thank you for watching this video.